chat with your databases, your relational databases mainly, the SQL-based databases. So if you can guess from this particular picture, like I'm asking, what are the best-selling products for this summer? So it will go to the database, it will search to the different tables, and it will be picking up the best-selling products for me in a natural language way, in our human understanding natural language way, not like writing any SQL queries or maybe database procedures, nothing. So why it is so important nowadays? Because the data is growing. But before going into that particular things, maybe like is thinking like, what is this? Talk to your DB. So far, we have done like SQL queries. We have created our programs to go into the databases and create like APIs. And on top of those APIs, we are building our applications, right? But here part is saying like, you can directly talk to your DB. That means we do not require the SQLs. We do not require the complex SQLs. We do not require the database procedures, the data modeling, or even we do not require to create the application programming interfaces APIs for our applications if we can directly talk to our database itself, right? So that's the topic we are going to explore today, right? Why it is important? Because the data is tremendously growing. If you see the stats, 50% of the data got generated in last 2-3 years itself. You can see in this particular stat, it's saying like volume of data created, captured, and copied and consumed worldwide. The data growth, like these are in zettabyte, okay, and you can see the exponential growth of data. And in our previous episode, we have seen how we can get the information and query different things, get the solutions from our different problem statements from different unstructured data like PDF, CSV file, text document, and so on and so forth. Today, we are going to see a different paradigm, like how to then talk to the structured data, which are there in your relational databases. Okay. So as because I wanted to cater the people who are thinking, what is this? Let's first get into a quick demo, what we are going to see, how it is possible, why it is possible, and those kind of questions we can answer from there. So if I have this, so this is kind of like simple UI where I'll be talking to our databases. Like I will be chatting to the databases by just typing here and run program. It will go to the databases and it will extract the relevant information for me. I already have the database. In this particular scenario, I am using the Postgre. I'm just opening the PG admin to open up the PostgreSQL database, which is one of the relational database. But don't worry, we are going to see the HANA cloud as well. So this Postgre is installed in my local computer, but we are going to see the HANA cloud as well. We're going to see HANA cloud. So that means you can literally talk to your production database like HANA enterprise level HANA database as well. Okay. So here I have the Postgre databases locally installed in our local host. And you can see I have this particular schema, okay, public schema, and I do have a table. I do have two tables actually here. So employee salary and employee. And in this particular two tables, I do have some data as well. So I do have some relations in between those tables, employee and employee salary. So to keep it very simple, I just kept it like this. I have some ready-made query. Let me just see. So I can ask something like, so first of all, just to understand how it is behaving. So describe all the employee related tables. Okay, if I'll just ask this thing in natural language, it will go to the databases and it will pick up the relevant information for me. And here it is. The employee related table in the databases are employee salary and employees. Now, if I will just modify the query a little bit and say like with all the fields, and how they are related. So it should now give me the entire possible relations and all the fields in those tables, employee salary and employees. So just wait for a second. Here it is. The employee related tables are employee salary and employees. The employee salary table has fields this. The employee table has fields this. The employee ID field in the employee salary table is foreign key referencing the employee ID field in the employee table. So it can understand everything, right? What are the relations as well in between the different tables, right? But little bit this is technical, right? So whoever will be actually using this kind of applications maybe like not technical person. They don't care about the tables and relation and all. So I can query like whatever as a functional guy or business guy, I can query something like, okay, now tell me like who is getting the highest salary. Let's see. It should come up with the result. And in between, how actually it is working. If you're wondering how actually it is working, we learned about LangChain. We learned about OpenAI ChatGPT in our previous example where we were using the unstructured data. So here also we are using similar technique. I'll go and walk through the step by step how it has been done, but we have used similar technique here as well. Now you can see the result. So when you go back to the database, you can see this is the data I have in my database. So who is getting the highest salary? If I just go back to my database, Postgre database, if I just open the data, where is that? Let me just open this. Query tool, select star from employee salary and execute. So you can see 7,000 is the highest salary and it is with the employee ID 3 and employee ID 3. If you go to the employee table, you will see the employee, this employee, select start from employee. I'm just trying to show you how actually the data is in our databases and how it actually returns the data. So 7,000 salary, the employee ID this, Mike. Mike is the right answer. And actually it is giving me the right answer here in our output, Mike Johnson. So similarly, you can ask anything and everything. Maybe like I will complex my query in a natural language way, okay? And tell me the name and email ID, please. So it should now give me the name and email ID as well. Just wait for another few seconds. Mike Johnson, this is his email ID. So you can just check the email ID as well to cross-check, to cross-validate Mike Johnson. Okay, maybe I will just complex it a little bit more. Okay, and how much he is getting now. Whatever, I have done some spelling mistake. Let's see. So it should give me the accurate answer. The accurate answer is 7,000 US dollar. Yeah. So Mike Johnson at example.com, $7,000. So this is how you can see it can navigate to your databases. It can understand the different tables, the different fields, the relation between the different tables, and then it can come out with appropriate answers as well. So isn't it amazing, right? So now you can think about, what are the possible use cases. Let me just go to our PowerPoint. use cases are very interesting. Maybe you are in a company where your functional folks, or maybe just I'm just drawing it like this, like you have your business guys, business user, you have CXOs like CEO, CFO, and whoever it is, or maybe the functional consultants. We wanted to empower them. They should not be dependent on us, right? So that's the main purpose here. So how we can do it? So as of now, whenever they have some kind of requirement, they generally come to your data analyst, right? So let's say like this is your data analyst, or maybe they can come to you as well as a ABAPer, or maybe SSC consultant, the analytics consultant, or if you are a data modeler, they can come to you if they want some kind of report from your databases, right? So it can be like SSC consultant, maybe data modeler, or even ABAP developer as well, and asking you to create some report based on these are tables and this is the business requirement. What you generally do, you go and create the report based on the different tool, and you query it from your databases, be it like HANA database, SQL database, Oracle database, Postgres database, any database, right? All relational database. So it can be, as I was mentioning, the SQL database, the PostgreSQL database, or even HANA database as well. Okay. So now, as because we wanted to empower this group of people, because as I was mentioning, the data is growing tremendously. It is not always possible, maybe in future, to program the reports, right? Always based on the requirement. Maybe the CXO is asking something now, in the evening, they need something else as well. So you will not go and program it and then give it back to him after 1 month, then the opportunity will go away, right? So for that kind of purposes, we are wanted to empower those kind of people. So what we'll do is we'll be writing the code or our program or application a single time, right? And if we'll be giving the application to them, they will be able to give the input and take the output, like I was showing just now before this. So this is our problem statement. Now you can imagine like where we are going, where we are actually moving. So that means what are the different possibilities? The possibilities are, I was talking about the SQL query. It can do the different SQL query. It can create the different views. It can create the different complex queries as well, or it can do like the different joins, right? Joins between different tables, right? And maybe like it can do the advanced joining. So advanced joining are something like self join, cross join. So some kind of those joins, okay, like subqueries, right? Or maybe like we can also use SQL functions. So you will see those things in some time. So that means like we don't have to write those SQL structured query language. Instead of, we can directly talk to the database with our own natural language way, right? The SQL functions are like aggregation functions, the string function, date functions. So all are gone. So you don't have to write the code. You don't have to be skillful on that area as well. Like even the window function, or not only that, you can also do the error handling, or maybe like the performance optimization, and even the database procedure, and so on and so forth. And even not only those queries, but also you don't have to build the APIs out of it, right? We can have seen it is not required anymore to create the APIs and then give it to the front end developer. It is now seamless with natural language itself, right? You give the input in natural language, it will also give the output in natural language. So how actually, before going into the coding area, I wanted to just tell you what are the different techniques that we have used or different tooling we have used. So in our previous example, also here also we are using the LangChain. And we are also using the OpenAI APIs. And of course, like we do have our relational databases. Previously, we were using the unstructured data. Here, we have the structured data. So whenever you are actually querying something and giving the input, it actually goes to the LangChain. So this is the internal mechanism just I'm now sharing with you. And in the LangChain, we do have a SQL agent. So that goes to the OpenAI. And OpenAI, so if I say, tell me the average salary of the employees in a natural language way. So it goes to the OpenAI and it converts those natural language question into a structured query language, SQL language, right? And it gives back again, to the LangChain. And then LangChain again, with using the query that was returned by the OpenAI ChatGPT, it goes to the database. Like again, it goes to the database. And let's say it finds out the corresponding table, it finds out the corresponding fields, it finds out the corresponding relation, it finds out what to do actually. If everything goes well at the initial go, then it will return the actual result, right? So that's the main purpose, correct? It can return the actual result. And the actual result can be the output for the user. But let's say you are asking some complex thing. So we'll see like what would be the complex thing. Let's say like imagine we do have employee table, but you are asking like how many workers are there? There is no worker table, right? But OpenAI ChatGPT can understand worker maybe employee, and it can try to find the close related tables and relations. And based on that, it can actually query it back again to the database. So what will happen if initial go, the result will not come? Then probably LangChain will again ask it to the OpenAI, give me the correct SQL. Okay. So in that way, so this is kind of like chain of thoughts. This chain of thoughts happens, okay, through this LangChain orchestrator. And again, the OpenAI will give some of the prominent query SQL statements, and LangChain will again go to the database and try to find out the final result with the final refined version of the SQL. And if everything goes well, again, it will go back to the LangChain and it can give you the output. It can give you the output like this. So this is how the entire chain of thoughts will be orchestrated by the LangChain. Of course, with using the OpenAI's APIs and your database connections. So now if you have some idea about it, what is going on, let's move into the coding part and understand how it actually happens. Again, I'll be using this VS Code, and as because I do have two projects today, okay, so HANA project and PostgreSQL, and this was the previous day's project where we were able to create our own custom ChatGPT by using the unstructured data. So now today we are dealing with Postgre. I do have this Python file, okay, Python notebook actually. So if you're wondering, I don't want to learn Python. See, that doesn't matter if you are doing ABAP, if you are doing JavaScript. So it's almost same. And even nowadays, you don't have to generate the code, write the code by yourself. You ask ChatGPT. I was showing you on the last day itself. If you ask ChatGPT, it can give you the appropriate code as well. If you have to actually prompt it appropriately what actually you want. So like that, I have also generated this code by using ChatGPT. I have not written the code by myself. Okay. So this is the code. And of course, like this is kind of like self-explanatory code, but still let me just explain what is going on. So I have included some of the packages from LangChain. You can see these are the lines. I have included borrowed some of the packages from the LangChain library. And I do have .env where I have given the API keys and all. And I do have this constant file where I am putting the database connection details. Okay. And I have these things. I am just executing it. Okay. It got executed successfully. So if you don't know about this notebook, so in notebook, you can actually execute some code. Okay. So it's not something like entirely you have to execute the whole code, right? If you want to execute the code in a structured way, okay, then you can actually use notebook. But anyway, so you can actually put the entire code in the .py file and you can also execute. That's how we have shown in that particular UI screen, right? We have given everything. So our entire code is there in this api.py, chat.py, and constant.py. Anyway, I will be giving this code I will be sharing this code with you, okay, in GitHub. So you can also try in your own machine as well. So what next? The next set of code is actually connecting to the database. So here I am using the user, password, host, and database. So those details I already put it in my constant.py. So I already imported the constant.py in our previous piece of code. And now I am now using this connection. And after getting the connection, I'm using the SQL database dot from URI. So this is the function from LangChain itself. Okay, so when the connection is ready, and then I am using the chat model OpenAI. So you can also use in future if there are something else, maybe like Hugging Face or something else is coming up, you can also use the same thing. So if you learn LangChain, it can be applicable to any large language model in future as well. Of course, it will work in a similar way, in a seamless way. So there, what I'm doing is I'm using this model. So this is a kind of like stable model from OpenAI ChatGPT. And then I'm using SQL Database Toolkit, and I'm using the database and large language model, right? So like this, like what I was talking about, LangChain is using the OpenAI and database. So for my scenario, also LangChain is now having the database information as well as which model I am going to use those information as well. And when I have all the information, then I can use the create SQL agent from LangChain itself. And I'm just passing the LLM model, the toolkit that we have prepared now, and then varvos is true. And I have this particular object which I'll be using in my next section. So before that, let me just actually execute this particular section of code. Yeah, it got executed successfully. And now I have this particular piece of code where I'll be using the agent executor object that I created in the previous section .run. And here I'm just putting it the input from here itself, like I was doing it in my web application as well, right? So let's imagine like this, okay? And now why I'm showing this, I wanted to show the behind the scene concept, like how it is going. LangChain is actually going to the OpenAI and then bringing the result back and then going to the database and then bringing the result back, and how the actual final output is being generated. Those are the mechanism I wanted to show you because you are more from the technical background, right? You wanted to also build this kind of application for your customer, for your functional folk, for your business, for your CXOs, right? So that's the reason I am showing all those inside details, behind the scene details. Now I have this agent executor.run. I'm giving my input in a natural language way, English, plain English format, describe worker table, please. But unfortunately, I do not have worker table in my database. Let's see how it behaves. If I just execute this one, so what will happen? It will try to go and try to find out the result. So it is saying final result, the employee table has column this. But I did not ask for employee table. I asked for the worker table. How actually it happens? If I go to the scroll level element and I just expanded it, so you can see what is happening. Actually, you can see like actually there are first action happened from our LangChain SQL DB list table. So it goes to the SQL DB list databases. It tries to find out the different tables, schemas, and then it is the observation is okay. So in my database, I do have employee salary and employee table. This is the observation. Then again, there is another thought from our OpenAI. Okay, so with the help of OpenAI, it has the thought, okay, the table in the database are employee and employees, employee salary and employees. I should query the schema of employee table because maybe it is so relevant. Let me just check table to get more information about worker table. So OpenAI, as because large language model, they have this robust brain in the world. They are able to understand worker. There is nothing worker, okay, in our database. So we do have a employee table related to that. With that particular thought coming out from OpenAI, then it goes back again to the databases and it will now particularly search the employee table. So before searching to the employee table, it is trying to understand the employee table schema, okay, with different fields, and it is actually trying to get the data as well from the employee table. So employee table is having this data and the final thought. Okay. So when this is given to the OpenAI, and now OpenAI is now trying to figure out what would be the result based on the query, initial query by the user. Okay. So it is saying the worker table is actually called employee here, not our workers. And it has following columns like this. So now you can understand with combination of this orchestration tool or wrapper on top of the OpenAI ChatGPT, the LangChain, we are able to have the different action, observation, and thought. It generally called as chain of thoughts. Okay, chain of thoughts. So by this, we are able to successfully get the appropriate result from our database. So I can also ask something else as well. Let's imagine how much our company paid to all employees in total. So that means the query is going to be a little bit complex here because it might be wanting to sum up the numbers of different employee salary, like maybe like it will be using the some SQL function and all. But let's see how it goes. If I do this particular query, so what is happening? So again, it goes to the different table list. It is trying to check what are the possible things that user is asking. Based on that, it goes to the different tables, corresponding related tables, and then it is coming up with the final answer, 18,000. Okay, so if you don't believe, let's cross check it once again. If I just go back here, so the sum of this is 18,000 itself. Okay, now come back and see how it actually does. So if I just open this one, the actual SQL query it generated like this. I have not written the SQL query. So with the help of LangChain and OpenAI model, this particular SQL query got generated. Behind the scene, it also got executed, and also not only execution, it is also giving the result in the natural language way as well. So this particular SQL select sum of salary amount from employee salary. Okay, so it got executed like this, right? But let's say like I wanted to just get some result with joining of different tables. Okay, I can ask like this because employee master data and employee salary data, there are two different tables and they are related with the employee ID. So if I will ask like this, how much John Doe is getting now, it should go first to the employee master table to find the John Doe, and then it will go to the employee salary, and then it will combine both the table and it will give you the final result, right? So all these actual technical things will happen behind the scene itself. Let's execute this. Okay. So here you can see it is not only giving you the answer, but it is also giving you the answer in the natural language. John Doe is getting a salary of 5,000, right? So it can literally talk to your native language itself. Okay. So how it does, if I just scroll the elements, actually, what is the query? It actually executed behind the scene. And this is the query. Select salary amount from employee salary where employee ID in. You can see it is a subquery. Select employee ID from employees where first name is John, last name in Doe. Even I did not mention the first name and last name as well. It is so intelligent now. It is able to understand what is the first name and last name as well. Just imagine, guys. Just imagine where the world is moving. Okay, just imagine. So definitely you should invest some amount of your time and money in AI learning. Okay, so that is my message, entire message to you guys. And here you can see the query, this particular complex query got generated and it actually successfully executed, and it is also giving the result in the plain English format as well. Now what I was trying to mention you previously, like this, that means it is entirely possible to create views, complex queries, joins, advanced joins, subqueries, SQL function, window function, error handling, data procedures. Even you don't need the APIs. Now, you don't need to create the APIs. Why you will be creating the APIs? Where you can only talk in natural language to your actual data sources, be it like a structured data, unstructured data. Why you need to create the APIs? Why you need to write the Node.js code? Why you need to write the SQL queries? Think about that. Okay, so this is what I wanted to show you. But now I think like you got the entire message that I wanted to convey. Now you have seen this thing. Now probably you might be wondering, okay, so Partha is saying like it is possible to do this with this Postgre. Now to make you believe, because mostly you are from this SAP background, you have some understanding of like how ERP works. ERP works in the big database like HANA database and so on. So we can apply the similar thing in HANA database as well. Of course, possible. Yes, that is the possibility I wanted to show you now. For that, I will be just going to my database. I have my database. This is my database. Let me just connect to the database. And this is my HANA database. Okay, let me just check. Yep. So this is my HANA database. Here I do have a single table as of now. Okay, in this particular schema, I do have a single table employee table. I'm just taking a simple example. And here I do have a data single entry. Okay, Mike Johnson. And this is the details: employee ID, name, last name, email, department, and salary. My intention is to query or ask anything in my HANA database. This is my HANA database. Okay, and it should give me the result in the natural language. For that particular purpose also, I'll again go back to my code and show you how it actually happens. Now let me close this PostgreSQL, open the project for HANA. Here also I'll be opening this particular notebook, Python notebook. And the things are almost same. Maximum of the things I'm importing it from the LangChain. Okay, and also I'm using this one. Okay, so this particular package will be responsible to connect to the HANA database. I am now executing this one. It got executed. And also I am now connecting to the HANA database with almost the similar information: user, password, and host name and database information. And I'm also using the same model, the GPT 3.5 turbo model from large language model, OpenAI large language model. And I'm using the SQL agent. And here I am passing the LLM, the large language model, and the toolkit means like, okay, so what is the database and all. all the information, and I have this particular object, and when I'll be asking anything to this particular object, it should be giving me the right answer, right? So let's compile this particular piece of code. Yeah, done. Now, if I ask something like this, tell me the email ID of employee whose salary is more than 6,000. So of course, I do have a single entry itself, but anyway, so that should also give me the right answer. So here, this is the answer. I think it's still trying to compile, and you can see there are multiple thoughts are going on, okay, before finishing the result, right? Now, the final thought is the email ID of the employee's salary, so whose salary is more than 6,000 is Mike Johnson. Okay, the final answer is Mike Johnson. So if I just see the things in a query, select email from employee where salary greater than 6,000, limit 10. So this query got generated behind the scene. Okay. So just to prove like it is also connecting, it can connect to your ERP databases as well. It can also search through multiple relations between the different database tables, and it can also give you the proper answer. So that's the main purpose here. I guess like you understood what we are trying to do here and where the whole world is moving towards. So please attention to that. I would say nothing else. But that doesn't mean like everything will be seamless, right? So there will be different jobs for the technical folks as well. Okay, because there are different challenges as well, right? So what are those challenges? Let's understand those challenges part as well. So if I go back to my presentation and try to show you some of the challenges. So the challenges could be, so the problems are like there would be different problems like, okay, so generally if you see in SAP, the databases are not like the sales, employees, or those kind of things. They generally use some abstraction, right? So abstracted table. So abstracted table names, right? So like VBAK, VBAP, VBRK, VBEP, 𝐂𝐞𝐫𝐿, and so on and so forth. So those maybe like ChatGPT don't understand today as of now. But if you can train ChatGPT like we were doing in our episode number 1 with our own data, right? It can understand. But as of now today, if you wanted to solve that particular problem, you can go and use the CDS views instead of the raw tables, because CDS views having the actual human readable fields and actual entities, right? So if you can use that easily, that is possible, right? So because they're in the sales view or sales CDS view. So there is a sales CDS view. It is not called as VBAK, right? Like that. So ChatGPT or OpenAI can understand those kind of things if you are using the CDS views. Just I'm giving example from SAP. If you are using some other ERP, that other ERP also having some other possibilities. So that's where we have to play around. Like, okay, convert these things and then ask LangChain to query from your CDS view itself. Okay. And so this is one of the valid actually challenge. Okay, so these are the challenges. Other challenges, you might have seen the latency. So it was taking some time even when I was having a less amount of data, even the less amount of table, right? So how to overcome that? Maybe if, as because we are giving it to the chat GPT, but if you are giving the training at your on-premise server itself, it will be faster in future. So that's where your job will come into picture. Okay. So and of course, like okay, so let me just, so it takes time, right? Takes time to give you the output. This is another challenge. And other challenge would be the security. You don't want it to actually hook up your database with this OpenAI. Maybe like they will be extracting all your sales information, customer information, which is this sensitive information, right? So for that purpose also, we have to use some other different technique, like I was showing you the Azure OpenAI instead of the ChatGPT or OpenAI, the actual OpenAI APIs. So enterprise grade OpenAI from Azure. So those are the things you have to use. So those are actually the simple thing, as because here I'm using the OpenAI, you just have to replace with Azure OpenAI. That's it. Everything is same. Everything else is same. Okay. So like this, these are the challenges which where we will be having some role to play around. But just imagine now. So where the world is moving, guys. That's all from my side. And see you tomorrow or see you in some of our next session. Thank you, guys.